Welcome to the New Jersey Institute of Technology website and math podcast. My name is Matan, and today I will be talking about the product and quotient rules of exponents. When multiplying two numbers together with exponents of the same base, the product rule of exponents can be applied. The product rule is this: those two numbers of the same base multiplied together is equal to one new value with the same base as the original two, and an exponent equal to the sum of the exponent of the first two. For example, 5 to the power of 2 times 5 to the power of 3 is equal to 5, we keep the same base as these two, to the power of 2 plus 3. We add the two exponents together to get the new exponent. This is 5 to the 5, which is 5 times 5 times 5 times 5 times 5, which is 3,125. If two numbers are being multiplied together with exponents that do not have the same base, as in this case, 2 to the power of 3 times 3 to the power of 5, the product rule for exponents cannot be applied, and this expression must be evaluated without that rule. Some other examples that do use the product rule are 2x cubed times x to the power of 5. We take the two instances of x to a power and combine them into 1 by adding the powers. So we have 2 times x to the power of 3 plus 5, or 2x to the power of 8. In the case of x to the power of 7 times x to the power of negative 7, we have x to the power of 7 plus negative 7, which is x to the power of 0. And any number to the power of 0 is 1. In the case of negative 4y squared times 3y to the 7th, we group the numbers in such a way to use the product rule of exponents. So we have negative 4 times 3 times y to the 2nd times y to the 7th. Grouping this way, we see that the y's follow the product rule of exponents. The 3 and the negative 4 multiply to be negative 12. You get negative 12 y to the 9th, where 9 is 2 plus 7. The quotient rule is similar. If there are two numbers that are dividing each other with the same base but different exponents, we can write this as a new expression with the same base and one new exponent of the first, the one from the numerator, minus the exponent from the denominator. So for example, 5 to the power of 3 divided by 5 to the power of 2 is equal to 5 to the power of 3 minus 2, which is equal to 5 to the power of 1, which is equal to 5. Some further examples of this: 5 to the power of 10 divided by 5 to the power of 10 is equal to 5 to the power of 10 from the numerator minus 10 from the denominator, which is 5 to the power of 0, or 1, which is what we would expect from dividing a number by itself. 2 to the power of negative 1 divided by 2 to the power of 3 is equal to 2 to the power of negative 1 minus 3, or 2 to the power of negative 4. This is the reciprocal of 2 to the power of 4, or 1/16. Finally, if we have x to the power of negative 3 divided by x to the power of 5, you get x to the power of negative 3 minus 5, which is x to the power of negative 8, which can also be written as 1 over x to the power of 8, the reciprocal. Thank you for visiting the NJIT website. If you need any further assistance, stop by the Center for Academic and Professional Enrichment in Coop Free Hall, room 200. Good luck in your studies.